What's up, guys? Welcome to our first CAD tutorial. This is stupid. Alright, so today we're going to be discussing the basics of Autodesk Inventor 2019 because 2020 sucks. Alright, so we're just going to learn about our basic extrude function, our revolve function, our sketch function, and probably how to move around a little bit, right? So here's our plan for what we're going to do in this episode of
What the fuck is that?
Shit. Win. Alright. Alright, now we got our updated board here about what we're going to learn about today. We're going to learn our basic controls, our basic sketch functions, and some constraints, alright? Gamer stuff. It's CAD time, alright? Alright, cut it. Guys, this is a weird intro, but let's get right into it, okay? So the first thing we're going to learn how to do in Inventor is make a new part, alright? So we're going to go over here to New, click New, and we're going to learn about the rest of this later, but for now we're just going to make a standard IPT, which is just learning for part. I'm going to let that load up. Alright, so now that we got our first part created, we can go and we can start to create a part, okay? So we can go up here to our sketch function, and for now we're going to start with a 2D sketch, alright? So right here, we're going to learn about our different planes, okay? So we can choose a vertical plane that's facing you, a vertical plane that's facing this way, a vertical plane that's facing this way. So basically you have a 3D space to create a new sketch on, okay? So I always select the XYZ plane, so I'm making a flat part while I'm looking down at it. It's just easier for uses later on, alright? Now that we've created our first sketch, we can start to create our first part. However, before we start doing that, I think that we're going to go ahead and learn about our controls. So the first thing that we can do to move around and look at our part a little better is we can hold down our middle click button and we can drag. This lets us pan around our object a little bit easier. Second thing we can do is we can hold down our middle click button and we can hold down the shift key, or actually flip that around. We can hold down our shift key and hold down our middle click button. That lets us rotate around an object. Now if you'll notice, the top right hand of my screen, the little cube, is rotating as I rotate. That's your little, that's your orientation finder. It's called a view cube, I think, and that helps you orient yourself, right? So say I get all mixed up, I don't know where top, down, or bottom is anymore. I can go over here to this cube and I can click top, right? Just because I like it to be like that. I like the top to be facing me. It's just easier. So you can use this cube to easily change your view around to say you want a side view of the front. You can flip this around to the left side, back side. You can't tell right now because we haven't made anything yet, but once we do, you'll be able to see what we do. Alright, so some few of our basic sketch elements. Say we want to make a line, we click over to the line button, and we can create a line anywhere. So say I want a line right here, right? So I can click my first position, and then I can click on my second position, right? Now until I click escape, we're always going to be continuing to create lines, alright? So I'm going to keep on pressing, and the line's not going to go away until I click the escape key. Now the line is gone. I can't create any more lines until I click the line button again. A lot of people get confused with this. It's kind of funny. But we're just going to delete all these. Just click Control Z. We don't need these. Alright, our second function we can do is we can create a circle. Again, click anywhere on the thing. You create a circle. Click. Click. There's my circle. Unlike the line key, line function, we do not create more circles unless we click escape. That's how this one works. Alright, Now, just to expand on all these functions, say we want a line, right? I clicked in the middle because it's always good to start your stuff in the middle. And say I want this to be, I don't know, you see how my inches is highlighted right now? As I move, the inches increases or decreases. Say I want this line to be exactly 20 inches. What I can do is I can type in 20, right? And then I can click enter, right? That puts me right at a 20-inch line. Say I want 20 centimeters. Type in 20 space cm. There's a 20 centimeter line. So it automatically converts it to 7.874 because I have my part set to the superior number system, which is the American number system. I'm just kidding. That's just what we do. So, for example, say I want to do some quick math in there. Say I wanted to calculate, I don't know, the diameter of this. No, we'll do a circumference, which is pi d. So say we want to do 3.14 times our diameter of the circle, which we will hypothetically say is like 240 inches. So we'll just do 3.14 times 240. So it'll do the math in there for us, which is super nice. So we'll just erase all that again. Another thing we can do is not only can we choose our length of the line, if we click the tab key, you'll notice that the length is no longer highlighted. Now it's the degree that's highlighted. So now the length is always going to stay fixed because that's the number I've entered. Now I can enter in whatever degree I want. So say I want a 45-degree angle. This is my 45 degrees. Say I want a, I don't know, a 2 radian. I had 2 radians. It's really whatever you'd like. Yeah, that's our key input functions. All right. If we move over to, well, we'll go back to the line key. These are a little bit more advanced. Say you want to make an equation for your curve. This is all fancy stuff. I don't think you'll ever do this in robotics, but I did have a friend who wanted me to make a 3D object of a graph. So you input your y value and your x value, and then these don't matter really. Your max and mins. You're making a graph basically. So what you put in a calculator is what you put in here. It's kind of, we would never use that. For our circles, these are really important. Arcs are important. We'll get to that later. We're going to roll with the rectangles. All right. So here's our 2-point rectangle. Again, click here. Click once. We can make it whatever size we want. Say we want the top. We're messing with this top number right here. So we want it to be, I don't know, 800. Click the tab key. That one's set now. I can't change this length. I can only change the height now. Say I want this one to be 300. Click tab. This is all set. I can't move it unless I go in here and change that to 400. And the way I'm switching between these, I'm just clicking tab again. And whenever I get this set right, I'm going to click enter, and then boom, I got my thing. All right, that was a 2-point rectangle. Pretty straightforward. We have our 3-point rectangle, which is a little bit fancier. We can go up here, type in a number, click the tab key, set it to exactly what we want, then we're going to click enter. And now we can set our length, which, I don't know, 500. Then boom, we have our 3 points that we set. That's kind of overkill. I don't ever use that. This is the 2-point center is one I use normally, because normally it's nice to have your part centered. You'll see why later. But the nice thing about this is you can set your part up, and then you can choose whatever length you want. And it's always going to be in the middle if you click in the middle of your part, which is always a good thing to do in my opinion. Alright, what else do we have here? 3-point center. This one's kind of odd because you're choosing the center line of your side length. So say I make this one 60. So if you'll notice, it made the center point of my height to what I just said. So if I go back to here, click it again, we're choosing the height times, yeah, we're choosing the height right now. It's ridiculous. I don't know why anybody would want to use that, but you know, it's there. It's useful sometimes. All right, slot functions. I don't think we'll ever use. Maybe a little bit. Not right now though. Polygons are really useful. If you'll notice, any of the hex shafts you've ever messed with in the lab, those are all hexagons. You can't make a hexagon. Well, whenever I didn't know how to do this, I used to take a line and do it all by hand. It really sucked until I learned about this polygon tool. Just click in the middle of your object, and then boom, you can create a polygon. The sad thing about this is there's no length adjustment like the other ones, so what you have to do is you have to go up to your line function, say I want a, I don't know, a polygon that's 1 inch, I don't know. Oh, well, that's way too small for this. Make it 100. Okay, go to our polygon tab. I want 6 of them on hexagon. Up to here, there's 100 point-to-point hexagon. Now we can do the flats as well if we select this over here. And so rather than doing that, we can select our flats, which is also nice. Yep. Those are all of the important drawing sketch functions we have here. Fillets are also nice. What this will do, if you select 2 edges, it'll create a rounded edge. These are really nice for gearboxes and tension load situations. I'm just going to make this like 2 inches. Click enter. With a 2-inch fillet. You can't really tell because it's 100 inches. It's massive. Alright, another good thing to know about is the trim function. What we can do is we can choose a line, and as long as this line intersects another line at some point, which this one is, it's going to trim that line and then leave the excess. Rotate tool rotates our object. I'll go and do that, I guess. So what we do here is we select what all we want to rotate. So I want to rotate the whole thing, and we have to select a center point, right? So I'm going to select the center of this. We're going to remove the constraints so we don't care. Alright, we can put in a specific degree here, so 90 degrees. Boom! Rotated. Alright, yeah, okay, those are all good to know. I'm going to delete this all. Alright, so say we're making a hold plate. Say I want a plate with a bunch of holes in it. I'm going to go and make these holes. Oh, God, I'm going to make them. Normally it'd be 0.25. I'm going to go and zoom in. I don't know why I haven't zoomed out so much. So say I had this, right? But I wanted this to be on a rectangle, like a rectangle plate. It's like a plate of holes, right? I can do that. I can say we already had the rectangle made. That was just me throwing it out there. We can use our rectangle tool right here. We can select the geometry we want to have duplicated, which in this case would be that circle, right? And then we can select our direction 1, which in this case would be along this line, and then our direction 2, which in case would be along this line, right? So now we're duplicating in the upward direction and the downward direction, or in the side direction, right? So because I don't want these holes to be created down here, I'm going to go ahead and click this button and flip my geometry upwards on the direction 1, flipping it along that axis. Right, so now I can come over here and I can select the quantity of holes I want. So I think it's going to look about 13, 16, oh, 15. Alright, 15 in that direction. If I come over here, this will give me how far apart I want mine. So say I want these to be 0.5 apart. See, I just edited that. So the center of each hole is 0.5 apart. Same thing with this one. I'm going to want 30 at 0.5. Oh, maybe not. At point. We don't want 0.25. I'll go with 0.5. Whatever. Anyway, so we can make a matrix of a massive amount of circles. It's really nice to do. So the mirror function, that's really nice. What we can do here is we can mirror our objects. So say we don't want to cheese a whole gearbox. We can cut the gearbox in half, cheese one half, and then mirror the other half. So that's what I do a lot. We choose our selected geometry and we choose a line we want to mirror over. I'm going to choose this line, click apply, and then we have a mirror of this object. Alright, so a few more things we can learn about here is we can go and make a line. Go and make another line that's like that. Another key element in creating sketches are these constrain functions right here. Here's our parallel constraint. What we can do is we can set this one as our master, set this one right there, and we can set these two lines parallel to each other. That's pretty useful. I'm going to have to delete that though. Here's our perpendicular function. Set this to this. Wow, they're perpendicular. Wow. That's cool. Don't really care about that though right now. And then our tangent function is also really useful. Those are about the only ones you'll use. But yeah, that's also pretty useful. Okay, so let's go ahead and let's go ahead and make a part. I think go ahead and make a part. Yeah. All right, guys. Now that you know a little bit about the sketching we can do, we can learn about creating 3 objects out of our sketches. Okay. So I'm going to go ahead and do what I like to do is create my rectangle in the middle because I like to do that. Get 5 by 5. Alright, and then let's click our finish sketch button. Alright, so now we have our finished sketch. We're back in our 3D model view. we can do is, if you want this to be a cube, or however we want to do this, we can use our extrude function, which is just going to set this up. So you want it to be 5, boom, click OK, but we're not going to do that yet. It'll make us a 5x5 cube. There's more things you can do with this. Say we click this, it'll make our 5 inches go in that direction. Say we click this, 0.25 on top, 0.25 on bottom. Say we do this, we can set different lengths, so the 0.5 on top, 0.25 on bottom. If I switch this, do that, and then if I switch this, it'll swap the two. Not super difficult. We're going to make this 5. Alright, so say I wanted to put a hole through it. I can click my sketch function again, and then I can go to any face on here. I'm going to go and choose the front. And what I can do is I can create a cylinder. Not a cylinder. I can create a circle in the middle of this that will show me where the middle is, and you'll see. So if I make this 5, because that's a length that we already know, divided by 2, we already know it's going to be 0.25, but say you don't know it. Same thing here. We can drag this all the way up. Green little dot means we got it all the way. We know it's 5. 5 divided by 2 is 0.25. That's the middle of our square, our cube. So all we can do is we can go to our circle, click in the middle, because we just made that middle, and make this 0.75. Now we'll make it like 3 inches actually. Okay. Finish your sketch. Click our extrude function, and then we can extrude this, but it's going the wrong way. So what we can do is we can do one of two things. We can select direction 2, which would go the other way, or we could go ahead and just click the cut function, which is what we want to do. We want to cut through our object. So here we go. As you can see, it cuts right through. Okay. Oh, whoops. Clicked on the undo button. Whoops. There we go. We got our cube with a hole through it. Alright, so another function we can use is the revolve function. We can go to a create new sketch, go up to here, go up to our, create a line. I'm going to make a 90-degree triangle. Okay, we know it's 90 degrees because this is perpendicular, but say you got it off, go up to here. So these two perpendicular, and then you're done. That's a perpendicular triangle. Alright, click our finish function, and then we can go to our revolve. So now we're going to select what we want to revolve around. This is already selected, it's the only sketch we have in the object, and then we're going to click what axis we want. So in this case, I'm going to go and select this one, and that'll make us a little cone here. Pretty cool. So say I don't want it to be a full cone, say I want it to be like a 3/4 cone, I can go into here, click on 270 degrees, and boom, 270 degree cone. There's a lot you can do with this revolve function for fluid shapes. Alright, so now let's move on to some challenge problems for you guys that might be pretty cool. Alright, so for the first part we're going to create, let's go ahead and let's make a cube at 1.125 and 1.125 on both sides. And let's put a hole that is centered in the middle with a diameter of 0.5. Alright, that'll be part number 1. Part number 2, I guess we'll go ahead and make a cylinder that is, it's terrible. Yeah. It's 8 inches in length and has a diameter of, let's say, of 4 inches. Okay, part number 3. Let's go ahead and make a churro. Let's make a 0.5 hexagon. Which I don't even know if I can draw. Yep, that has a radius of 0.5. Alright, and for our last part, our challenge part, let's see if you guys can make I don't think I can draw this, I don't know if y'all can tell what it is. Let's make a sphere. Let's make a sphere with a diameter of 2 inches. So if y'all can do that. Try it on your own first, and then I'll get back to you with the answers. Alright, the answer to challenge problem 1. Go over here, create a sketch. Again, I like to put mine in the middle. You'll see why right now. 1.125, 1.125. Click enter. Alright, I'm going to go and put my circle in the middle before I extrude, so it's already there. I'll have to go in and do it again. Click right there. Boom. We wanted this to be a 1.125. And then boom, we got our 1.125 with our 0.5 hole in the middle. All right, answer number 2. We wanted a cone that had a 4-inch diameter. Okay, finish that. Let's go and extrude this up by 8 inches. And boom, we got our 4-inch cube. Or, not cube, we had our 4-inch cylinder. As you can see, it's at 230 right now, so it's great. New parts. Our third thing we wanted to create was, look back at it, was a hexagon, 0.5 flat end, 0.5 polygon 6. Select this one to be flat. Boom. Finish this. I don't think I said how big to extrude it, so it's however size you want it. Boom. Alright, and the last one, the challenge one, let's do the sphere. Let's see how many people got that one right. So, normally what I do is I just make a circle. What was my length? 2-inch diameter. Alright. Just take that, put a line right down the middle, and then just revolve this all the way around. That's the easy way to do it. Finish. Revolve on the axis in the middle. Boom. Have a sphere. Yep. Those were the challenge problems. Alright? Alright guys, that's enough learning for today. Let's move on to our question of the day. This one's from Emily.
What is the airspeed velocity of an unladen swallow?
God damn it. I said robotics question. This is... Alright, you know what? We're going to do some big boy math, okay? Yeah. Be right back. Alright guys, it's 3 a.m. I got the math done. Alright, so if we take a look at this infographic right here, we first need to ask ourselves, is it a European or an African swallow? That's a pretty important question. Being that this is probably from Monty Python on the Holy Grail, I'm going to say it's a European swallow. Alright, so with doing a little bit of math and some research online, we can figure that the average wingspan of a European swallow is about 12.3 centimeters because the Europeans will do most of this in metric gross. Alright, so we can go and do some more math and we can look up and see that the average mass is about 20.3 grams, which is also kind of important. So what we're going to do here is we're going to track the average airspeed using our wavelength calculations. Alright, so the way we're going to do that is we're going to use this fancy number I found online called Schruhall's number. Alright, it's a ratio between 2.2 and 0.4 something or other. So we can just graph that. Right, here's our graph of our 0.4 st. Right, so we have these at 0.22 for the wingspan per beat, and then our 0.5 would be the total length that it would take a bird to go from fully extended to unextended to back to fully extended. So one beat of its wings would take us about 0.5 meters. All right, same thing down here, but with our wider number, which would be at a 0.2. We travel about 1.1 meters with, again, our 22 meter distance for our wave height. Alright, again, wing up, wing down, 180 no scope, wing back up. Alright, follow me here. So instead of doing both these because I'm lazy, I just took the average. Right, so if we average both these lengths out, it's about a 0.73 meter per beat length. Alright, right at a 0.3 st. So 15 beats per 33 meters. Alright, that's important. If we go back here and do some more big maths, we can figure that 15 beats per second is about 0.73 beat, or at 0.73 meters. So that's 15 beats. Yeah, math. Alright, so we got 11 meters per second, right? So yeah, basic math here. And that converts us to 39.6 kilometers per hour for all you Europeans out there. And then for Americans, we got our 24 miles per hour. All right? Basically, this swan's going faster than your grandma on a highway. Okay? Thank you guys for watching. Don't give me any more crappy questions, please. That took me way longer than it should have. It's 3 a.m. I want to go to bed. Okay? See you guys later.